Once again, happy day! We are going to discuss about our chapter 2, lesson 5, that is electronic configuration for our Chem 16th class. I am Levitah Castil Mapatac, your instructor. So here it is. By the way, what is electronic configuration or electron configuration? Actually, this will describe how electrons are being distributed in the atomic orbital. So, electronic configuration of atom, this will follow a standard notation in which electrons contain the atomic sublevels, which we had discussed in our quantum numbers. So, the sublevel, of course, will be designated with S, P, B, F. And we already know that S has 2 electrons, maximum of 2 electrons. P will have 6 electrons, B will have 10 electrons, and F will have 14 electrons. So, the number of electrons is being written on its subscript, and that S there will stand for S, that is SPBF, will stand for the sub level, sub energy level. What is the importance of electronic configuration or the electron configuration? This will determine the valency of your element. This will predict the properties of the group element. So for instance, in group 7, you have to know its charge is -1 and they are halogen groups. Group 1 are having a charge of +1, group 2 +2. Why? Because they exhibit, why is it that they are grouped that way? Because they exhibit similar properties. So one of its usefulness also, this will interpret the spectra in your atom. And this notation of the notation of your electronic configuration, this will show you the distribution of electrons in the atomic orbital, which is being practiced by Bohr model first, and this was being presented by Rutherford way back 1913. So how are we going to write the electronic configuration? We already know in our quantum number that you have the value of the main energy level, that is, can you still remember it? That is the N. What's the formula for getting the number of electrons? That is 2n squared. So if our N is equal to 1, how many electrons will be in N is equal to 1? That will be 2. 1 times 1. 1 equal to 1 times 2. There will be 2 electrons. For N is equal to 2, that is 2. Then 2 times 2, 4. 4 times 2, 8. There will be 8 electrons, so on and so forth. For N is equal to 3. Okay, that is 2. 3 times 3 is equal to 9. 9 times 2, 18 electrons. This is where we get this number, maximum number of electrons for. So this N is equal to 1, that is K shell. How many electrons? There will be 2 electrons. For the L, that is N is equal to 2, there will be 8 electrons. When N is equal to N shell, that is N is equal to 3, therefore 18 electrons. Looking into the principal quantum number, N is equal to 1. We already know how many electrons will it occupy. That will be 2 electrons. Therefore, that will be your resulting configuration is 1s2. As I have said, this one there, here, that is 1s2. This n here will be your, value of 1 there. So n is equal to 1. Then your s here is known as your sub-level. Then this will be the number of electrons. So if you are going to have the value when 1s2, what will be the value of your n? That is 1. What will be the value of your L? The second quantum number, that is 0, because we already know when it is equal to S, that is 0. What will be the value of M sub L? That will also be equal to 0. And what will be the value of your M sub S? That will be, it will have that orbital there, that is 1 electron, 2 electrons. Therefore, up is positive 1/2, down is negative 1/2. Your value here will be negative 1/2. That is for n is equal to 1. You get it? So, when n is equal to 2, how many electrons? There will be 8 electrons. So, in these 8 electrons, as you can see, what are the values of your electronic configuration? That will be 2s2 and 2p6. Take a look. Count it out. That is how many electrons? The superscript there will tell you the number of electrons, that 2 plus 6 equals to 8. When n is equal to 3, therefore, you will have these values, that is 3s2, 3p6, 3d10. How many? Count it out. That's 10 plus 6 plus 2, 18 electrons. Okay. So that is for your n is equal to 3. This is your electronic configuration when n is equal to 3. For n is equal to 4, okay, how many electrons do you have? Can you still remember? There will be 32. Therefore, that is 4. The values there are 4s2, 4p6, 4d10, and 4f14. Count it out. That is 30. This is equivalent to 30 plus 2. Therefore, that will be 32 electrons. That is for n is equal to 4. That is the configuration of your n is equal to 4. So, how are we going to fill out our atomic orbitals? According to, by the way, atomic orbitals was discovered by Aufbau principle. According to Aufbau, it has a short term of buildup. Okay, this will dictate the number, the electrons that occupy. What are its orbital? Electronic orbital will depend on its number of electrons, at the same time its sub-level. So that is for Aufbau. It dictates that electrons will occupy the orbital having lower energies before occupying the higher energy orbital, meaning it will not go to the next orbital without passing the lower energies orbital. Okay. So the energy of the orbital is calculated by the sum of the principal and the azimuthal quantum number. So in this principle, this will be the order of your electron configuration. Of course, it will start with the first energy level, 1s2, then second energy level, that is 2s, 2p. Third energy level, that will be 3s3p. Fourth energy level, that is 4s3d 4f, so on and so forth. That is according to Aufbau principle. So this is now the order of the filling of your electron configuration. So start with 1s, it's spiral, 1s followed by 2s, then 2p, 3s, then 3p, 4s, so on and so forth. So this is the first energy level, the ground state. This will start with the excited state, that is N2, so on and so forth. Another principle which has something to do with the electron configuration is the Pauli's exclusion principle. Okay. According to this, there will be 2 electrons in each orbital. That is why you have plus 1/2 and negative 1/2. According to Pauli's exclusion principle, there will only be 2 electrons that can occupy in an orbital, but they will have it in opposite spin. Okay, that is why it is represented by an arrow up and arrow down. In this principle also stated that no 2 electrons in the same atom have the same values for all quantum numbers. Therefore, if the principal, azimuthal, and magnetic number are the same for 2 electrons, they should have a different S value. That is the opposite spin. The third rule, that is the Hund's rule. This describes the order which electrons are being filled up in the subshell. It states that in every orbital in a given subshell, this will singly occupied by electrons before the second electron is filled up. For instance, you have, this is known as, this is P. Okay. How many orbitals? There will be 3. So how are you going to fill your orbital here? It should have the lower first, that is up, 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 then go back, that is down, down, down. This is in order to maximize the total spin of the electrons in your orbital. Okay? So looking into this example, that is 1s2, of course, this is your orbital, the spin, 2s2, 2. So for 2p2, how many electrons? There will only be 2 electrons. And how many orbital you have here? You have 3 orbital for p. This is the x, y, z. Therefore, because there are only 2 electrons, it should be filled to the next. That is up, up. This is wrong. This is incorrect. Because you should fill up first the next orbital before filling the filled up orbital. So this is what as I have said, the representation of your configuration. This is the energy level, or this is now the N. This is known as your sub energy. That is the sub level. This part here is the number of electrons. So for example, we have oxygen. We already know that oxygen has 8 electrons. Okay, so how are we going to fill it up? How are we going to have it in the electronic configuration? So, how many electrons in the first? That is 2 electrons. Then followed by, because there are only 8, followed by 6. Therefore, it will have from this here. Okay, so if you will have 8 electrons for oxygen, therefore following this filling up of your configuration, you will start with 1s2 followed by 2s2. There are already 4 electrons. Then the next is 2p. Okay, but what is lacking is 4 electrons only. Okay, so that will be your electron configuration for oxygen. Here. So that will be your electronic configuration for your oxygen. So here is the illustration. This is now our nucleus. Our K shell, how many electrons? There will be 2 electrons. Okay, then the next shell is the main shell is another 6 because there are only 8. That is 1, 2, 3, 4, 5, 6. This is now our illustration. Okay, so in the L shell, how many? There will be 2s and 2p for the L shell. This is only 1s2. Here you will have 2p, 2s2 I mean, and 2p. It should not be 6 because it will exceed. There should be 4 only. Okay, so this is now your electron configuration for your oxygen. Another example is chlorine. Chlorine has 17 electrons. So this will have how many? This will be in the third energy level. That will be your K will have 2 electrons, that is 1s2. Your P will have 2p, 2s2 and 2p6. Okay, there are already 10. Okay, then for your N shell, that is the third, that will be 3s. This is already 10 plus 2, 12, then 3p, 12, there will be 5 only. That will be now your electron configuration for your chlorine. We could also write it using the noble gas configuration. For instance, noble gas is on the 8. They are stable. Okay. So for helium, that is 1s2. This one because there are only 2 electrons. The number of electrons in helium is 2. Neon, we have 10 electrons. For argon, we have, so for the noble gas configuration, we can make use of this helium, that is 2 electrons. Neon, you have this, neon is 2 plus 8, 10 electrons. For argon, you start with neon. How many electrons are there in neon? That is 10. Okay. So, that is now your argon is 18. Therefore, your noble gas configuration is have it in parentheses neon specifying 10 electrons, then 3s2, 3p6, so on and so forth for krypton and xenon and radon. Okay? So how are we going to fill out now our electronic configuration? This is the same throughout. You can follow this or you can memorize this, or else you can use the orbital filling, the one which I had presented, this one. You can make use of this. Okay, by Aufbau. So, for instance, lithium has 3 electrons. Therefore, that is 1s2, 2s1. How are you going to count the number of electrons on the superscript? That is 2, and 1, 3. For boron, there are 5 electrons. That is 1s2, 2s2, 2p1. Okay, here, that's 5. For aluminum, 13. Therefore, that is 1s2. This is being followed, isn't it? Okay, so aluminum, that 1s2, 2s2, 2p6, 3s2, 3p1. That is 13. And argon. Okay, that is how to fill the electronic configuration of the element. But this one could be filled up by means of, these are so-called, here are the symbol, helium, then electronic configuration. You can browse on this, okay, for more example of our application of electron configuration. For the noble gas notation, you can make use also of this as a shortcut. That is for helium, that is He, then 2s2. That will represent how many electrons? 4, and that will be our beryllium. Okay. For magnesium, magnesium is 12. You already know that neon is 10. Okay, so use the neon configuration plus 3s2 to come up with 12 electrons. For calcium, we already know that calcium has 18. For the argon, for the noble gas configuration, your calcium has 20 electrons. This 18 plus 2, therefore 20 electrons. That is for calcium. And for strontium, you use your Kr, that is noble gas configuration of krypton, which is 36. Okay, 36 plus 2, that is 38. So on and so forth, to make it simple. So that ends our lesson about electron configuration. I hope that you learned something, and our example will be posted in your Google Classroom later on for you to practice on it. So thank you everyone for listening. Keep safe and have a nice day.